My name is Dan Walker. I'm with the Metal Building Manufacturers Association, and I'm also joined today with Jay Johnson of the Metal Building Manufacturers Association, and our special guest today is Miss Anna Nicholson from UL Environment. This is going to be a presentation today talking about environmental product declarations and also introducing you to some new EPDs that MBMA has created. I'd like to let you know a little more about MBMA as an organization. We were founded in 1956, so we're celebrating our 60th year in existence this year, and we're very proud of that. We've got 43 metal building systems manufacturer members who are part of the organization, and they are joined by 59 associate members who are suppliers to the industry. We are very active on social media, and we've got a YouTube channel, a Twitter account, as well as LinkedIn, which is full of information that you can get from us, and you can interact with us in that way if you care to do so. All the contact information is there. We also have a website, and from the website you can find a list of all the member companies who are a part of MBMA. So I'd like to introduce our presenter today. As I said, her name is Anna Nicholson from UL Environment. Anna is ULE's Environmental Product Declaration Project Manager and works to develop strategic planning programs that drive business value from the use of environmental life cycle information as the basis of decision making. As a life cycle assessment certified professional, Anna understands the complexity of developing industry-wide life cycle assessments that have been summarized in the 3 MBMA environmental product declarations that we'll review during this webinar. MBMA engaged ULE to develop industry-wide EPDs based on prior work done by the metal building industry. At this point, we'll switch over controls to Anna, and she can explain more about EPDs, how they're developed, and how one might use them in the marketplace. So Anna, I'd like to switch control over to you.
Good afternoon, everyone. Thanks for that introduction. Before we get started, I'd just like to let everybody know if you could please hold your questions until the end of the presentation and type in the chat box. And please note the slide number that we're on if you have a particular question you want to ask. We'll have sufficient time for Q&A at the end of the webinar. So in the last few years, building product transparency started to gain traction in North America. Changes in consumer expectations, building certification systems, and international laws and standards have finally begun to converge in a standardized corporate reporting about any number of environmental, social, and health impacts. And many in the design community as well as the manufacturing community are developing ways to easily communicate some of this information through what is often called a nutrition label of sorts for building products. And international tools have been developed to easily communicate some of this information through what is known as the Environmental Product Declaration. So today's webinar learning objectives are to identify the global demand for environmental product declarations, also known as EPDs, in the building industry, to provide an understanding of how transparency and life cycle analysis or assessment impacts the EPD, to explore the importance of product category rule development in EPD development, and also to assess the limitations of EPDs and benefits for making smarter product selection decisions. And by attending today's webinar, you will be eligible for the continuing education credits that were mentioned in the original invitation, and these will be provided by UL Environment. So before we get started, there are a lot of letters and acronyms thrown around in this space, and I just want to make sure everybody is centered around what some of them mean. So pretty sure everybody is familiar with ISO, or the International Organization for Standardization. PCR, that's product category rules, and those describe the scope and methodology for performing a life cycle assessment, which is the data foundation or backbone for an EPD. And they provide the detailed requirements and guidelines for environmental information disclosure. It's known as basically step 2 in an EPD process. LCA, or life cycle assessment, is a widely recognized tool outlined in ISO 14040 and ISO 14044 to assess a product's impact throughout its entire life cycle or value chain, from raw material acquisition to end-of-life disposal or reuse and recycling. And then SPC, Sustainable Product Certification, test the manufacturer's product to independent industry standards to determine that the product itself, its manufacturing process, and materials in the product are in compliance. Products that have been certified will carry an SPC, or Sustainable Product Certification mark. There are also 3 different types of labels laid out in the ISO 14020 series, types 1, 2, and 3. And type 1 is what is typically referred to as a third-party certification, and these verify compliance in accordance with a specific government standard. Some examples include EcoLogo or the UL Sustainable Product Certification. Type 2 are self-declarations typically made by the manufacturer of a product and are considered less objective. So UL Green Guard program is an example of this. And then type 3 require independent validation of a product's environmental impact, and this is what an EPD qualifies under. So the ISO 14020 series, 14020 provides general information. 14021 is a type 2 standard. 14024 is a type 1 standard. And then 14025, which governs the creation of EPDs and PCRs, is 14025. So what we're going to be focusing on today is type 3 labels, EPDs. So what is an EPD? It's a type 3 label, third-party verified and internationally recognized. And it's a single transparent disclosure of a product's impacts throughout its life cycle. And something that is worth noting about EPDs is that they're absent of value judgments or claims in the marketplace. They're not communicating preferability. They're simply transparently communicating a product's environmental impacts. EPDs can be thought of like green product nutrition labels, if you will. And this is actually the EPD done on primary structural steel frame components for MBMA. This is the cover page. And it shows the certification label for UL environment and then some basic information about the product as well as the industry group. And we can think about an EPD like a summary of a life cycle assessment. A life cycle assessment is a very robust, comprehensive report that can be between 50 and 100 pages. They're very long documents that contain many, many sections which explain all the assumptions and calculation rules that go into reporting the environmental metrics of a product. These rules and assumptions are largely covered in the product category rule, the PCR, which allows for the presentation of just the results from the study of the LCA. So you conduct the LCA and then the EPD basically extracts the primary information in a much more concise, market-friendly format. So what are some of the market forces that are driving the demand for green in today's marketplace? Well, there's a global green building market, and it grew from 2013 to $260 billion approximately, including 20% of all new U.S. commercial real estate construction. Commercial building owners are expected to invest $960 billion globally through 2023 on green existing built infrastructure. When surveyed, 63% of construction firms had new green commercial projects planned between 2013 and 15, and around 71% of U.S. project specs reference LEED credits. And clients are also driving the demand for green. 70% of consumers are consciously searching for greener products. And new consumers consider the entire life cycle of a product and how their actions are creating not just near-term impacts, but ripple effects that will last today, tomorrow, next year, and a legacy for generations to come. So we have to think beyond the immediate needs to the impact on future generations and users. They're more concerned with what's contained in the product, how much electricity it will consume, how long it will last. And EPDs provide the quantified environmental data based on LCA and ISO 14025 that consumers can use to identify and weigh different environmental risks themselves. Clients can also be thought of as institutional and commercial purchasers who are also demanding green. They're more conscious than ever before, and they want their children, families, and workers to be healthy and are looking into what makes up the products that they buy. In addition, they want to feel good about the companies that they purchase from. In both B2B and B2C markets, people want to buy from brands that speak to them and from brands that they trust, and they ultimately want authenticity. In the world of sustainability, the need for authenticity, credibility, and truth is often mitigated by eco-labels. However, this has led to the emergence of over 400 eco-labels and has left many consumers and purchasers really confused about the credibility of environmental and sustainability claims. While eco-labels are still very important in today's marketplace, they're useful to differentiate eco-friendly products. But there's also a move towards greater transparency. And the combination of an eco-label with transparency-based disclosure tools will give consumers and purchasers confidence in their buying decisions and confidence that the claims on which they're basing their purchases and the companies that they support align with their values. Who wants EPDs? In a study conducted by MindClick SGM, architects and designers were asked about their green product certification preferences and what information will be the most useful to them when they specify products. But anyone who touches the product will be interested in what the product has to offer. So manufacturers, how can they make a better, more transparent product? Procurement officers, how can they decipher what's in a product and why is it a better purchase and what are its ROI implications? Consumers, safety is foremost in their minds, but ROI is important to them as well. Suppliers, there are many product options available and suppliers can choose to use better products. And contractors, with education on how to use EPDs to create synergy with what the architecture and design community is recommending, better products lead to fewer environmental impacts and health impacts. And there are also many programs that exist as well as programs that are emerging that encourage the use of EPDs through specifications and credits. And really, you can't have one. The purpose of this slide is to focus on you can't have one without the other. While you want transparency, which is driven through Type 3 eco-labels or EPDs, you need achievement to also prove that the product attributes are scientifically proven based on consensus-based standards. So showing that performance aspect is also very important and goes hand in hand with transparency. To speak a little bit to the North American EPD demand, 9 out of 10 architects and designers have researched, sourced, or purchased a green product in the last year. From 2015 to 18, the green construction spending is forecasted to grow 15.1% year over year to $224 billion. The top 3 reasons for specifying or purchasing green products are to help clients experience a greener, will provide clients with a greener experience for building users, help clients be sustainable in comprehensive and authentic manners, help clients meet sustainability goals. And what are the green criteria of highest importance? Well, 77% of business professionals said that products with third-party certifications are more reputable, which is easy to understand. And 3 out of 4 manufacturer-created green labels tested as confusing in the Claiming Green study that was cited before. And then 93% of consumers chose a certification as one of their top 3 factors for choosing a product. So this notion of independent certification does carry a lot of weight in the market, so much so that many green building schemes in North America are driving EPD adoption. and that includes LEED version 4, we have ASHRAE 189.1, IGCC, Cal Green, and Green Globe, to name a few. We also have on the right side of the slide consumer packaged goods and appliances. And though EPDs aren't required in the U.S. at the federal or state level, there are purchasing mandates that are creating de facto requirements for manufacturers. There was an executive order 13514 issued in October of 2009, which requires U.S. federal agencies to leverage federal purchasing power to promote environmentally responsible products and technologies. And the GSA is expected to incorporate these standards in EPDs in the next few years. And given their spending power of approximately $6 billion annually, this will speed up the adoption process of environmental standards. And then the very educated consumer today wants more information. The Sustainability Consortium is currently developing a measurement system that's based on life cycle assessment and PCRs for use by consumers. And retailers are asking for much more environmental impact data of products as well. I used to do consulting for both Target and Walmart, and they've developed supplier scorecards which have been used to report environmental information and understand more about the implications of the products that they're selling. Just to talk a bit about sort of the demand drivers from an international perspective, we have BREEAM, which is a high-performance building program in the UK, EU, Australia, and New Zealand. It's basically their equivalent to US GBC's LEED, and they've incorporated a reward for manufacturers who disclose info through environmental product declarations. In France, we also have the Grenelle Environment 2 law. This is a law that was passed in 2007 that requires EPDs for all mass-produced consumer goods. And it was launched in 2011, and the pilot is now finishing up and will be the basis of sector implementation policies, which remain to be seen, but it sets some ambitious targets of reducing the average energy consumption of buildings nearly 40% by 2020. And keep in mind that doesn't include just like HVAC systems or electricity. It also includes the embodied energy included in raw materials that are sourced to build the building. And then we have the last item on the list, which is the EU Product Environmental Footprint, or PEF for short. Those pilots are being conducted. Some have finished up to establish processes and categories that will be used to create the equivalent of an EU-wide EPD used to benchmark all products and support international efforts towards enhanced coordination and labeling development. And it's also been floated and talked about that this notion of benchmarking through PEF, which is a type of EPD, will be the basis for market entry and discussions of eliminating the worst 20% performers from even entering the market for sale. So just to talk a little bit about some of the aspects of EPDs, how they're useful as a tool that can drive results. They can be used as a management tool for manufacturers, purchasers, procurement, and purchase functions of an organization, for product designers, and for marketing strategy by monitoring product data and applying outcomes to improve environmental performance. They can also be used as a communication tool for manufacturers, suppliers, distributors, purchasers, contractors, and users by functioning as a source of environmental information while enhancing environmental awareness and interacting with internal environmental concerns. They're also a strong evaluation and assessment tool for folks who are using the EPDs for making decisions and for benchmarking environmental information. And by doing so, you avoid greenwashing in favor of objective, unbiased data and avoid the FTC jumping down your throat. the green guys. They're also a procurement tool for government, commercial, and institutional purchasers. And last but not least, they're an action tool for consumers and consumer groups who are interested in disseminating environmental information and product criteria, as well as making comments and asking for disclosure of consumer concerns. So EPDs are useful because they are objective. As I mentioned before, they're absent of value judgments of environmental preference. So they're objective and based on internationally accepted and valid methods for life cycle assessment to identify and focus on the most significant environmental impacts, and that leads towards continuous improvement. They're credible in that they're critically reviewed, approved, and maintained by an independent verifier. And I went over the neutral one. They're open to all products and services. Through its neutral character and non-selectivity, it has the widest range of applicability to products and services. A lot of times people don't realize that EPDs and the science of LCA can be applied to any number of things. And while it's been focused in the building and construction community because of the specific demand drivers we see, we can also apply this science to any number of things. I did some consulting in the past for Fox Home Entertainment. They were interested in understanding what the environmental impact was of delivering 1 kilobyte of data to their customers. It can also be a way to compare purchasing goods from an online distributor versus a brick and mortar. So services, very much so, as well as products. They are open to all interested parties through easy access on the internet. The role of the EPD program operator means that they have to publish all EPDs in a registered, publicly accessible database. They are environmental impact oriented. That's pretty self-explanatory. And that they are instructive. They explain all the terms, definitions, and concepts, as well as general information on the relevant environmental issues to help with the interpretation of the information. And they're designed to enable comparability. So product category rules for the selected product groups and services describe a harmonized method of rules for data collection, the methodology, calculations, and presentation of the results. So without EPDs, environmental information would be highly inconsistent and uncomparable. But with product category rules, EPDs allow for a greater level of comparability between EPDs. And we can think of PCRs as kind of like mini standards for each product category for which an EPD is produced. And the PCRs determine the type of information that's reported on in the EPD and include guidelines for creating the LCA upon which the EPD is based. So because we have these fundamental guidelines which are consistent between one product and the next within the same product category, that information is going to be reported on and calculated in a consistent way. So we're avoiding, as represented in the slide, an oranges to apples comparison. So with EPDs, comparing the information that's derived from LCAs is more like comparing apples to apples, because the instructions and guidelines allow for more consistent environmental output for products in the same category. But really, I like this slide because, as you can see, there are different varieties of apples on this slide, and that's very much consistent with what's going on in the field of EPDs to date. We have Granny Smiths and Washington apples and Red Delicious, and this characterizes some of the uncertainty inherent in life cycle assessment. And we're working on developing methods to address this uncertainty and characterize how that affects our decision making, so that we're more likely to compare Granny Smith to Granny Smith in the future. These are issues that we're striving to address with our partnership with USGBC and others. I think I've gone over what EPDs are in terms of being an evaluation tool. And the process for creating an EPD requires multiple elements to create a final product in the marketplace that's been vetted and will ultimately make sense. So to create an EPD, you need at least 3 parties, consisting of a life cycle assessment practitioner, an LCA verifier, and then an EPD verifier. So an LCA is actually performing the calculation. An LCA verifier is making the statement that all the information in the LCA is correct. And the EPD verifier, which is a third party, makes the final assessment of acceptance, making sure all that information has been reported correctly, has been followed the underlying requirements in the product category rule. And you might need potentially up to 4 parties. This is not too often the case as we've moved into a more mature time of EPD development, but sometimes there are no product category rules. And we'll need a 4th party to develop the PCR that is the cornerstone for the EPD process, because without that set of rules, you really can't go forward with creating an EPD. In accordance with ISO 14025, an existing PCR is to be used whenever a suitable one is available. And sometimes there are PCRs that have been published in other markets, other geographies, that can be harmonized and adapted to North America. That's generally not as painful of a process when that's the case. But EPDs are very much market specific. We have North American specific standards, industry units. So that's very much specific to EPDs. And it's the role of the program operator to develop product category rules with input from a committee that's assembled that can consist of industry groups, manufacturers, NGOs, government organizations, anyone with an interest in that particular product category. So the steps in getting an EPD, each element builds upon the next to create the final EPD document. So starting on the left of this diagram, the first step is to select a program operator. And UL Environment is one of several program operators in North America. We have the largest repository of EPDs published. We're close to 600 to date. So once a program operator has been selected, you search and consider the available product category rules. This search is often done by the program operator. So again, just to level set, PCRs provide the scope and method for performing an LCA and the data foundation, which is the data foundation for an EPD. If necessary, a new PCR is created. This step is only necessary if there are no relevant PCRs for the product or if the PCR is out of date. And the program operator is responsible for creating the relevant PCRs through that committee process I mentioned on the previous slide. The next step, assuming that a PCR is published and ready to be used, is to conduct and then verify the life cycle assessment. And this can be completed by an internal resource or by a multitude of life cycle assessment consulting services. The next step is to then create the EPD, which, for example, UL Environment has a specific template that's used to report that information from the LCA in a consistent format, and extracting that information from the LCA in the appropriate ways that's determined by the product category rule. Once the EPD has been created according to that template, it's then submitted to the program operator for verification and registration, and the program operator publishes the EPD to an indexed public database. So while the program operator is not the main puppet master in this whole process, they do play an important role in the transparency of an EPD and guiding this whole process. I'd say the majority of time in this whole process is spent conducting the life cycle assessment and actually going through and gathering the necessary data components at the enterprise level be used in the LCA. That's assuming there is a product category rule, because if a PCR doesn't exist, it can be a very timely process to develop those rules and get the necessary consensus needed for publication. I mentioned this, but just to go over on a slide what the process is for creating a PCR. There are currently hundreds of PCRs available for use, but we're still in the process of developing many new ones on a regular basis. We have 5 in the hopper, for example, right now. So to start off the process, the program operator goes through the process of selecting a PCR committee, and all proposals are ultimately brought forward by organizations who want to be leaders in sustainability, and if a PCR doesn't exist, and initiating that process with the program operator and helping form that committee. Then the committee works together to draft a version of the PCR with guidance of the program operator, and the PO ensures conformance with the necessary ISO standards. And then once a draft has been finalized, it's then posted for typically a period of 30 days and disseminated via listservs and just generally communicating that the PCR is available for public comment and revisions. These comments are then considered by the original committee, who then responds to the comments and revises the PCR as necessary. Per the ISO standard, the draft is then submitted to an expert panel comprised of at least 3 experts in the field, typically an industry expert as well as a life cycle assessment expert. And once all of those comments have been addressed, a final letter of conformance is issued, and the PCR is published and available for public use. The whole process is similar to standards development. It can be completed in as quickly as 12 to 14 weeks. But I just finished the PCR for hand dryers, which took us about 1.5 years to complete. That was more in-depth in nature because it was global in scope, and so we had a lot more language barriers and logistics issues in coordinating our meetings. So it really depends on the scope of your PCR and how many players are involved in the development process. Since we've gone through EPDs and PCRs, the final component in our alphabet soup is the life cycle assessment. The life cycle practitioner continues down the path of creating an EPD and conducts the LCA. And LCA is a widely recognized tool for the assessment of a product's impacts throughout its entire life cycle, from raw material acquisition to end-of-life disposal, or hopefully reuse or recycling. The LCA is the structure for identifying and assessing the many environmental impacts that products have, And instead of conducting like a carbon footprint, which some of you may have heard, an LCA shows the impacts across a variety of different environmental indicators. So looking at like acidification or energy consumption, water consumption, eutrophication, which is a very big word, but means the nutrient overloading of bodies of water, which lead to like algae blooms and deaths of aquatic species. So we're looking at a whole host of environmental impacts in the LCA to really understand the trade-offs that occur between all of these different life cycle phases, because maybe our carbon footprint goes down significantly in production due to sourcing a new material, but maybe there's much more pre-processing energy that goes into that material that we're sourcing. So LCA is really a way to systematically quantify and understand those trade-offs and environmental impacts that occur across the value chain. LCA consists of 4 different steps. First is the goal definition and scoping, which is to define and describe the product, process, or activity, and establishing the context in which the assessment is to be made, and identifying the boundaries and environmental effects to be reviewed for the assessment. And most of that, if not all of that, has already been specified in the rule, the product category rule, that's going to be informing the development of that life cycle assessment. So the goal would be creating an LCA for the outcome of publishing an EPD. The next step after the goal definition and scoping would be to conduct an inventory analysis. And that's where you would go through and at the facility level and gather data to understand and quantify the energy, water, and materials usage, as well as any environmental releases that occur, so like air emissions, solid waste disposal, wastewater discharges that occur. Then, after the inventory has been assembled, this inventory is mapped onto a variety of environmental impacts that assess potential ecological effects of energy, water, and material usage and the environmental releases which have been identified in the inventory analysis, and map each of these onto environmental potentials that can be caused. So global warming potential, acidification potential, eutrophication potential. And then finally, the last step, which really occurs throughout the whole process, is interpretation. Evaluating the results of the inventory and the impact assessment to select a preferred product or process with a clear understanding of the uncertainty and the assumptions that have been used to generate the results. When the LCA is complete in a very robust report, as I mentioned earlier, it's then submitted to a third-party verifier who considers all the data and the resulting information in the assessment. And typically there's a back and forth with some comments that have been found that are lacking in the LCA that need to be addressed. Once those are cleared up, then the LCA is ready to be reported on in an EPD. So MBMA went through the process of conducting a life cycle assessment. Here you can see the actual LCA, which was conducted by the Athena Sustainable Materials Institute. And this was the LCA for primary and secondary structural steel and wall and roof panel products. This LCA is available at the URL listed at the bottom of the slide. Just to give you some examples of the types of information which are contained in the LCA, on the right-hand side we have a process flow diagram considering all the different input materials, energy supply, going into the different processing elements that are required to produce these structural steel components. On the bottom we have an example of the impacts that occur it's not really legible, but global warming, resource depletion, acidification, some of those environmental impacts I mentioned previously are along the horizontal axis. And then it shows, the different bars show where those impacts are occurring in the life cycle of the product. So these are the types of graphs and charts and analytical tools that are reported on in the life cycle assessment. I think I've actually covered a lot of this information in the previous slide on LCA, but just to go over and highlight how systematic and quantifiable the science of LCA is. We have our inputs coming in on the left in the form of raw material and energy. We have them going into each of these different phases within our system. So raw materials and energy going into the raw material acquisition, into the manufacturing process. You may ask, well, why do you have raw materials going into manufacturing? Those could be in the form of ancillary materials. We also have the reuse, use, and maintenance cycle for the product, and then final waste management. And along each stage in the life cycle, we have various emissions occurring. Atmospheric emissions, water emissions, water in the form of water waste, solid waste. Sometimes we have co-products that occur in addition to the final product that's being studied, and then a number of other types of releases. But so LCA provides the backbone to conducting this comprehensive system assessment. So currently, MBMA has 3 published EPDs, one for primary structural steel frame components, one for secondary structural steel frame components, and the third for roll-formed metal wall and roof panels. These are available at the MBMA homepage at the URL listed on the slide. They're also listed on UL Environment Sustainable Products Guide at the Product Guide URL, and that can just be referenced, and you can search for MBMA and EPDs, and those 3 EPDs will pop up. This is another slide that reiterates the link between a system and its potential impacts. The LCA provides a systematic procedure for classifying and characterizing these types of environmental effects. I'm not going to spend too much time because I feel like I've already covered that in previous slides. But just some of the types of environmental impacts. I think everybody's familiar with global warming potential, in that it's driving climate change. Acidification can lead to acid rain, the destruction of natural resources, eutrophication, again, the loss of plants and animals in aquatic ecosystems due to oxygen depletions following algae blooms. Photochemical smog is a type of air pollution caused by emissions of nitrous oxides and volatile organic compounds. Abiotic resource depletion is depletion of non-renewable resources such as oil, coal, and metals due to their extraction and consumption. Waste is the bulk waste and hazardous waste created during each step of the life cycle of a product. And then toxic substances are substances which cause harm to the natural environment and or human health. But we've seen a departure of consideration of human health in EPDs. Through the recent development of tools such as the Health Product Declaration, we've typically seen that EPDs aren't the appropriate tool to be considering human health impact because the exposure and risk isn't appropriately captured in this assessment method. So to create an EPD, you create the EPD in accordance with the PCR based on your verified LCA. You submit for verification and registration, and then your EPD is complete. And EPDs are typically valid for a period of 5 years. Under our program, we require an annual attestation that the EPD of the product is actually representative of the product as sold on the market. And this natural expiration period of 5 years is to ensure that any significant changes in sourcing or processing is accurately considered and updated in the EPD, and that process has gone through or thought through again. So in terms of navigating the EPD, you've seen the EPD for secondary structural steel frame components. Again, this is our cover page, which shows a picture of the product, which is being reported on in the EPD. And we also give our clients an opportunity to tell a story about their sustainability journey and commitment to environmental reporting in the little gray box. And then underneath is the UL certified EPD mark. And then underneath the product images are a brief description of how the product is used and applied. Within the contents of the EPD, you have a product definition and information about the building physics. You have information about the basic materials and the material origin. You have a description of the product manufacturing. You have indications of the product processing. If relevant, you have information about how the product is used. You have the LCA results, and then the testing results and verification. And the next slide, this slide 34, gives some information that's extracted directly from the metal roof and wall panel EPD. You have the product description on the left, which describes how the products are commonly used. You have a description that talks about the design parameters, what materials go into the fabrication, and then you have some pie charts here on the right, which represent that material composition. The EPD also contains a breakdown of each of these environmental indicators that we've discussed. I know they're represented as acronyms on this chart, but I've highlighted one in red, and that is the total primary energy used to create the product. And from what we can tell from this particular bar is that over 90% of the primary non-renewable energy is in the raw material stage of the life cycle, with very small contributions from the transportation and manufacturing stages. So 90% of the energy from like fossil fuels, fossil-derived fuels, are embedded in the energy that's being sourced for this product. This slide gives an example of all the different environmental impacts and how they're reported based on each different phase of the product, which they've actually been aggregated here in A1 to A3. But this is just to give you an example of the tabulature, the format of how these environmental metrics are reported in an EPD. Looking at one more closely, GWP is global warming potential, and this value of 1,221.7 kilograms of carbon dioxide equivalent This value shows the potential that this product has to contributing to the rise of global temperatures due to the emissions of greenhouse gases that occur from cradle to factory gate. And cradle means raw materials through the manufacturing, transport and manufacturing of the product. Once the EPD has been created, UL Environment offers what's called an EPD Transparency Brief, which is a front and back simple market-facing deliverable that we found our clients really like, because even though an EPD is a distilled form of the LCA, they're typically between 15 to 20 pages, which still isn't a very customer-friendly way to present that you have an EPD and what the high-level impacts are. So we've created these transparency briefs to be really a marketing material, and this is just an example of an EPD for the primary structural steel frame components. And there's a nice little graphic that shows what the different emissions to air, land, and water are at the bottom. There's a blowout box showing each of those impact categories, and then the emissions of the product that align with each one. So to summarize, EPDs are a communication tool among manufacturers, suppliers, distributors, purchasers, contractors, and users by functioning as a source of environmental information while enhancing environmental awareness and interacting with internal environmental concerns. I've already gone over what the different types of eco-labels are. EPDs lie at the bottom, which are type 3 eco-labels, but they can be thought of as fitting in as a piece of a pie to an overall story with type 1 eco-labels, which seek to make environmental claims about products, as well as single attribute certifications such as indoor air quality or recycled content. So when considered all together, these types of eco-labels, 1, 2, and 3, can inform better purchasing decisions. In terms of where EPDs are going, with our partnership, the UL's partnership with the U.S. Green Building Council, we're looking at what needs to happen to facilitate appropriate, meaningful comparison of products that's based on the available science that we have. It's not acceptable to directly compare EPDs at this point, and ISO has strong language which says that we cannot do so. However, we are also exploring how we can use EPDs for benchmarking. There's an optimization credit in LEED right now for using EPDs and showing the reduction of environmental impacts across at least 3 categories. So what we're doing right now is developing definitive guidance that can be used for benchmarking to show this optimization credit, and that's for both companies that are producing individual EPDs that want to show reductions on the industry average, as well as companies that want to show just basic year-over-year performance improvement internally. We're also looking at major revisions to the standards which inform the EPDs in the building and construction space. Currently, the standard which for the building and construction space for EPDs is ISO 21930. This is currently under revision, and it's going to look a lot more like some EU standards, EN 15804. We're trying to anticipate the changes that means for the North American market. Is something we're trying to stay on top of. Increased visibility and recognition. We have established mutual recognition programs with various global program operators such as BRI and EBU out of Germany. So as EPDs gain traction, program operators across the globe have to figure out ways to recognize these EPDs, and we're challenged to do so under ISO, so that manufacturers and industry groups don't have to go to each geography and pursue EPDs with a multitude of disparate organizations. We're also looking at ways to develop tools that can streamline the whole process for rapid EPD generation. Tools that can be used to put in basic information about your bill of materials and basic processing information and tools, and outfit your EPD and LCA results that have already been verified in the tool itself. So rapid EPD generation is really going to democratize the whole process and make this process available to small and medium manufacturers, and really help drive EPDs to be used as tools to show performance improvement. So where do you get EPDs? EPDs can be obtained from the program operator database or directly from the manufacturer. Like I mentioned before, it's posted publicly on our Sustainable Products Guide as well as the MBMA website. So that concludes that portion of the presentation, but there's a little bit more. I just wanted to talk a little bit about UL environment, how we're an ISO 1425 compliant program operator. We are working to increase both the supply of and demand for products and services with a smaller negative environmental impact in comparison to alternative products by disseminating verified information on the sustainability aspects of products and services through PCR identification as well as PCR development services, and then full service EPD solutions. So whether that's company-specific EPDs, industry-wide EPDs, verification of tools used to create EPDs, we really cover a lot of different services. And then who exactly is UL Environment? For those of you that aren't familiar with what we do, we are a business unit of UL corporate. I typically think of them as the product and safety testing folks, but we are helping to grow the world's most sustainable companies by combining expertise in science and business, and we're helping leaders to build market share and grow profits and accelerate global progress towards sustainability. We're a full-service environmental solutions company. We provide environmental assessments, testing, and certification services to bring more sustainable products and services to market. We're a trusted source of environmental information and partner in sustainability. And we offer claim validations, multi-attribute product certifications, EPDs, indoor air quality certification, product emission testing, organizational sustainability certification, as well as consulting services. UL Environment offers the following tools as part of the presentation today, and they can be downloaded from ul.com/environment. Our sustainable product database, which I've mentioned at various times throughout this webinar. The LEED version 4 credit matrix and understanding how to navigate the credits available under LEED. Where use of environmental services can help with credit attainment. And then we provide educational resources, continuing education, and thought leadership webinars. This is an example. This is the cover slide for our Sustainable Products Guide, where you can find valuable information about how we test products, our services, and more. And it's searchable by product category, manufacturer, and sustainable building program credits. This is where the MBMA EPDs are available. If you go to the evaluation type as environmental product declaration over there on the left, and then under manufacturer, you have MBMA, you can see the 3 different EPDs that have been produced and published. If you click on the picture, it will take you to a page that has the actual EPD and transparency summary available for download. And these are some of the different marks, certification marks available from UL Environment. Just some examples, we have the UL certification for reduced environmental impacts. This is just an example, not for anything particular. We have UL Eco-Local mark. We have our EPD mark, Green Guard, which is for indoor air quality. And Green Guard exists at various levels. And then UL validation of a claim. So with that, I'd like to say thank you, and also go over some things that we've learned. So just to go through this list, EPDs offer information about key environmental effects such as materials, energy, and carbon footprint in a simplified and standardized format. True or false? That is true. Number 2, the equivalent to an environmental nutrition label, EPDs are also known as Type 3 eco-labels. That is true. Number 3, EPDs are developed following pre-established product category rules, allowing for comparison amongst individual products and services in specific categories worldwide. That's true. They enable comparison, although not direct comparison. I know that's nuanced, but ultimate comparison is the goal. Number 4, EPDs are an internationally recognized comprehensive disclosure of product lifecycle impacts. That is also true. Product impacts are assessed through ISO 14040 compliant lifecycle assessments and verified internally by manufacturers. That is false. We threw one false in here to throw everyone off. These assessments are verified by third party. Nothing in this process of getting an EPD is verified internally by manufacturers. So with that, I'd like to, again, say thank you for your time. I realize a lot of information was covered in the webinar today. Some of it new, hopefully some of it was a refresher for some of you, but I'd like to open the floor for any questions now.